Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we have another topic, that is interference of light. Okay, this the similar topic we have already studied in chapter number 8, but that was excluded from chapter number 8 according to smart syllabus. So we are studying this topic in chapter number 9. So it is defined as when two or more waves superimposed. Superimposed mean overlap on one another. Superimpose on one another, then their amplitude may increased or decreased is called interference of light. That is called the interference of light. Okay, so interference when two or more waves, suppose y1 is one wave, y2 is another wave, y3 is another wave, suppose, and so on. We are adding y1, y2, y3 and y4. These are the waves. When we add them vectorially, remember, waves are adding like vectors. As we have studied in chapter number 2, the addition of vector under certain conditions with certain angles. So we will add the waves as we add the vectors. So when we add these waves, these waves superimpose to each other or overlap on one another, so their amplitude x0 may increase or x0 may decrease. So x0 may increase, x0 may decrease. X0 means the amplitude. The amplitude may increase, amplitude may decrease. Okay. So this process is called interference of light. So remember, intensity and amplitude both are directly proportional. So if the amplitude is increased, intensity will also increase. Amplitude is decreased, intensity will also be decreased. So first we are going to study the condition for interference. The condition for interference are two. The frequency should be same, or the waves should be coherent. The waves should be coherent. But we are not discussing these two conditions. We are discussing the observation of interference. When we will observe the interference, so the condition for observing observation of interference, mean we want to observe interference practically. If we want to observe interference practically, okay, so the first condition is the wave should be coherent. The wave should be coherent waves. What is meant by coherent waves? Coherent mean if there is certain path difference, so that path difference must be constant. Suppose the path difference between the two waves is suppose lambda, so that path difference will be constant at each and every point throughout the waves. Suppose the path difference is 0, so that path difference will be constant throughout the wave. So remember, the path difference should be constant at each and every point. Okay. Coherent mean the path difference or the phase difference should be constant. Okay. The light should be monochromatic. Monochromatic mean the frequencies are same. Mono mean one, chromatic mean color. So monochromatic means single color, single frequency, means the frequency should be same, means the source should be same. If the sources are same, frequency will be same. So it means that interference may occur. So these are the basic two conditions for interference. But we are observing interference. So for observing, the amplitude should be equal x0. X0 should be equal or nearly equal. Equal or nearly equal to observe interference. If the amplitude is much different from one another of the two waves, if the amplitude of two waves is much different from one another, then interference will also be occur, but that interference pattern will not be observable. So these are the two conditions for interference only: coherent and monochromatic. So interference will occur due to these conditions. But to observe interference pattern, you should keep the amplitude equal or nearly equal. Okay. The light should be okay. The path of the waves from the two sources must be small. The path of the two waves must be small. Means the wavelength must be small to observe interference. Mean it should be in the visible region. The principle of linear superposition should be applicable. Okay. Means we cannot take the larger path of the waves, so that is why the waves spread out in every direction. When they spread out in every direction, so superposition principle, when we apply superposition principle, so we will face many difficulties. Okay. Now these are the certain conditions. For the fourth one, I should write it. The path difference PD means path difference of the wave between the two waves is very small. The path difference should be very small to observe interference pattern. Okay. These are the fourth condition to observe interference phenomena. There are two conditions. One is the constructive. These are two types. One is the constructive interference, and the other is destructive interference. What is meant by constructive interference? When the crust of one wave is fall upon the crust of other wave, when the trough of one wave is fall upon the trough of other wave, or when the compression of one wave is fall upon the compression of other wave, or when the rarefaction of one wave is fall upon the rarefaction of another wave, then the amplitude will increase. When the amplitude increase, intensity will increase. Okay. When the amplitude increase, intensity will increase. So if it occur in mechanical waves, so a loud sound will produce. These are the effects of constructive interference. When it occur in electromagnetic waves, a bright spot will produce. So it means that whenever constructive interference occur in the mechanical wave, so loud sound will produce. When it occur in electromagnetic, so bright spot will produced. Okay. Now we are studying the conditions for constructive interference. So remember, the condition for constructive interference is D is equal to m lambda. What is m? M is a whole number. So whole number means m is equal to 0, 1, 2, 3, 4, 5 and so on. If you putting the value of m, so we will have 0 lambda, 1 lambda, 2 lambda, 3 lambda, 4 lambda, 5 lambda, 6 lambda and so on. It means that when two waves have zero path difference, constructive interference will occur. When two wave has lambda path difference, constructive interference will occur. When two waves have 2 lambda path difference, constructive interference will occur. So when these path difference comes between the two waves, so constructive interference will occur. So these are the condition for constructive interference. Okay. Now look at the definition. Suppose this is y1 wave. This is y1. Okay. Remember, this is the mean position. This is the extreme position. So the distance between them is called amplitude. So this is the amplitude, and the direction of amplitude is up. Okay. This is another wave y2. This y2 is overlapping on y1. So remember, this is y2. Okay. This is the mean position. This is the extreme position. Okay. This is the mean position. This is the extreme position. So this is also an amplitude. So this amplitude have the same direction, which is up. So both the amplitude are in up direction. So both are amplitude in up direction. So according to vector quantities, when two vectors have the same direction, we have to add it. So this amplitude should be added with this amplitude. So when we add this amplitude to this amplitude, so this will be the resultant wave. This will be the resultant wave. So it means that the resultant wave will increase. The amplitude of resultant wave will increase. So it means that in constructive interference, the resultant amplitude will be the sum of the amplitude of each individual wave. Okay. So why we add the amplitude in constructive interference? Because the amplitude are in same direction. If the amplitude are in same direction, so we have to add the amplitude of y1, we have to add the amplitude of y2. So we have to add the amplitude of each waves. So that is why the amplitude will get increased in constructive and intensity will increase. So bright spot will produced. Okay. Now come towards destructive interference. Another is destructive